So this is part 2 of the video, and this is going to help you work through the homework on section 1.3. So this says, assume the rate of inflation is 5% per year for the next 2 years. What will be the cost of goods 2 years from now, adjusted for inflation, if the goods cost $480 today? So I'm going to change to the whiteboard so that I can write on the screen. And let's look at this question. All right, so this is for section 1.3, and it's our first example in section 1.3. And the question read, assume that the rate of inflation is 5% per year. For the next 2 years, what will be the cost of goods 2 years from now, adjusted for inflation, if the goods presently cost $480? All right, so let's find out how much the goods are going to cost at the end of the first year once we account for inflation. The goods are going to cost 5% of $480. So one way to solve this question is to multiply 480 by 5%. But remember, 5% needs to be written in decimal form. And 5% in decimal form, we move the decimal place 2 spaces to the left because percent means part of 100, so you divide by 100, which moves the decimal place 2 spaces to the left. So 5% equals a decimal equivalent of 0.05. So we're going to multiply 480 by 0.05, and that will tell us what 5% of 480 is. And 5% or 480 times 0.05 gives us 24. So at the end of year 1, there's a $24 worth of inflation costs. But $24 is not how much, or the value of whatever the problem said. I don't remember what it says. Maybe it was tires. I can't remember. But anyway, that's not the end value. That's how much the price increased. So to find the ending value at the end of year 1, you have to take the 24 and then go ahead and add it back to 480. And then you'll find how much accounting for inflation we have at the end of that year. Okay, so at the end of year 1, the cost is $504. Now at the end of year 2, it's still accruing at a 5% rate. So year 2, instead of beginning at $480, year 2 begins at $504. And we still have to multiply it by 5%. And we find that there's $25.20 worth of inflation at the end of year 2. But keep in mind that this $25.20 is not the ending value at the end of year 2. We have to go back and add it to the original value or price. And when we add it, we find at the end of year 2, we have a value of $529.20. And this is the final answer. And think of it like this. It kind of makes sense whenever you go out to a restaurant and you leave a tip, or if you go to the grocery store and you have to pay sales taxes, your final price that you pay is not just the amount that you've paid in taxes. It's not just the percentage. It is the total amount of the bill plus the taxes or plus the tip that you leave. Okay? Let's do another example from section 1.3. Bear with me again while I toggle between the screens so that we can pull up another homework problem. This problem asks, how much do 10 pieces of candy cost if 1,000 pieces cost $30? If 1,000 pieces cost $30. So there are several ways you can approach it. We can set up a proportion to solve this one. And I need to go to the white screen so that I can write. But let me snap a quick picture just so that I can remember these numbers. Okay, let's look at it. So, example number 2. So the question says that 1,000 pieces of candy costs $30. And then it asks us, how much would 10 pieces of candy cost? So one way to approach it would be to look at the cost per piece of candy. And we will approach it that way. It costs $30 for 1,000 pieces. Then how much would it cost? That's our X, our unknown, for 10 pieces. This is just one method to approach solving this problem. And then we have a proportion. To solve proportions, we cross multiply. So 30 times 10 equals 1,000 times X. 30 times 10 is 300. Let me make some more room on the screen. All right. 30 times 10 is 300, so we have 300 equals 1,000 X. And then we want to solve for X. We want to get this X by itself. So we are going to divide both sides by 1,000. So it cancels here, and we are left with X equals 300 divided by 1,000, which simply moves the decimal place 3 spaces, and we find that the answer is 3/10 or 0.3. And we would, if we were expressing this in terms of money, this is 30 cents. And that's the answer for example number 2. Let's look at a couple more of examples before the time runs out, and you should be good to go. But again, if you have any questions while you're looking at the videos or working through the homework, please feel free to reach out to me through Remind or through email. Let's see. The next question that I want us to take a look at is the income tax problem. Okay, so on this problem, it says the federal income tax rate schedule for a joint return in a specific year is illustrated by this table. If a married couple paid $13,381 in federal income taxes, find the family's adjusted gross income, and then it gives us the income tax table. So here's the deal when you're solving this problem. The first thing you have to do is identify which income tax bracket the individual is in. So if we're looking at this, the bill was $13,381. Okay? This column represents the taxes, which is the tax bill, and then the first column represents the person's adjusted gross income. So we're going to use the tax bill, which was $13,381, and see which one of these tax bill it's closest to. So $13,381 is not very close to, again, we're using our approximating or estimating skills that we learned in section 1.2. $13,381 is not very close to $1,675. $13,381 is closer to $9,362.50 than it is to $26,687.50. So the family is in this tax bracket that's represented right here. And I hope that you can see where my cursor is kind of toggling over. So let's look at how we would solve this. And then I'm going to have an additional video on this specific problem. All right. The family's tax bill was $13,381, I do believe. Let's see. Okay. So the bill was $13,381. And the family is in the tax bracket where they would get a bill that would consist of a $9,362.50 fee plus 25% of the amount over $68,000 in income. All right. So we're going to use this information and kind of set up an equation. The bill that the person got was $13,381. We're going to substitute it into the place for where I have bill written. So $13,381 equals $9,362.50 plus 25% written as a decimal is 0.25. So we're going to add to this 25% of what? Of the amount that the person makes over $68,000. So if we want to find the amount that the person makes over $68,000, we would be subtracting, okay? And now we're going to solve this equation. To solve the equation, one approach would be to subtract $9,362.50 from both sides of the equal sign. And once we do that, we will have a difference of, oh, my time is about to run out, so I need to hurry up with this. We'll have a difference of $4,018.50 equals 25% of X minus $68,000. And I'll record part 2 and pick up from this point.